should be the final pass. Normally, cast iron, we do not use any coolant or oil or cutting oil or something. I do this to clear the chips, and the finish will be way better. Of course, it makes a terrible mess on the machine. So now, in theory, this thing should fit in here. Yes. A little bit of wobble. That's good. Okay. Ready for the next step. And if you see the finish inside with coolant, it really is way better. I don't know if you can see on camera. Try to put some light in it. That's nice. The next challenge for this part was to make these slots to accept the ball bearings. The problem is there's only two machined surfaces. This one, the bottom, and this one at the top. So if I put my part this way, the slot is too high. I couldn't make it. The table is completely down, the tool holder completely up. So this was not possible. Because these are not machined surfaces, I could not install my part this way in a vise or whatever. And there was also the clearance problem. So the only option I had, do it this way. And then I used my extended tool holder, put in here, and this is how I did cut these slots. Unfortunately, there's no video. As you can see, actually I did film it. Now it's time to drill this 16mm hole in here. The axe that will pass through is 15mm. I have a 16mm drill bit, so there will be a 0.5 mm clearance for move around a bit if needed. Now I have to take measurements on non-machined surfaces, so it's a bit of a gamble. That looks good. I just finished drilling this pilot hole. This one is 8mm, and now I have a new problem. This is a 16mm drill bit. Way too long. This table is completely down. I cannot go lower than this, so I have to find another solution. I don't want to cut this drill bit because one day I will need the whole length or maybe even more, so I would like to keep it in one part. My good old Bosch. I wanted to show you this a little bit bizarre looking setup. The table is completely down at this lowest point and the part is still too high to clear the downside of the ram. So the plan is not to cut here but on the side. If I move the machine you will immediately understand the setup. Of course the clapper is moved in the direction of the cut. Always look at the cut, even in this weird looking setup. You just have to be careful that the dovetail of the ram will not touch the side of the workpiece here. But it's clear. Is to lower this part down, so this bearing will be just flush with that surface, maybe one hair under. Then I made this ring that will go in here, so I have to widen up this slot here. And the ring will be welded on a little plate that will be bolted on this machine surface. Big drills on small machines, not a good idea. But sometimes you have no choice. I made this bushing here to adapt to the crankshaft, and in the meanwhile I also made these two back plates. They're finished, so now the crankshaft is in place. That seems to work. I need another screw because this one is a bit ugly and crappy and way too long, but it goes all the way through. It pushes in the keyway here. Let's do a little bit assembly. And bit by bit it starts to look like something. This thing is gonna be the piston. It's a cast iron round thing. I don't even know where it comes from. And in a previous video I made this groove, so no problem, that's already in place. Now to line up to make this bore, I came up with an easy solution. I put my part in the vise and then lined it up parallel with this fixed jaw. and then looking for the high spot, and in theory that should be the center line. Now I don't know if it's the right way to do things, but for me it worked, no problem. Now it's time to work the outside diameter of this piston. I made a slug. Since I made it, it's never been out of the machine. I drilled and tapped this hole, put the rod in it, and this hole was already in this part, and it was drilled and tapped M10. So now all I have to do is screw it up here. The piston is finished. I drilled this, what is it? It's a 12 millimeter hole in here, and to be good, the pin that goes in here is a ½ inch, but I don't have a ½ inch reamer, and here in the neighborhood finding some ½ inch reamer is almost impossible. So my plan is to make this new pin 12 millimeter, and then I will make a little sleeve that goes in here, so I can use this same 12 millimeter pin goes through here. The sleeve I'm gonna make it in this, I think it's brass, we will see what it does. This brass and this aluminium, I hope they will be good friends, they will not argue. Now I have something really bizarre. Before I started drilling, I faced off this face, of course, and then I put a little center hole in, and then I started drilling, and when I drilled the 12 millimeter, you can see that the material came out, and the inside, the boring, looks perfect. This one goes in here. Of course the idea is to cut it off both sides, but I just wanted to show you, I never seen that before, the material coming out again of the hole. Piston is in place, a little bit of side play, it's perfect, wobbling around, perfect. Up and down, no play at all. That's good. Okay, now I can start make my measurements to see how high the cylinder will pass. And the cylinder we're gonna make out of this piece of round 70 millimeters cold roll. I want to keep the outside diameter at 70 millimeters, so I'm not gonna cut the part off. I'm just gonna clean it up with a little bit of sandpaper. Okay, time to slice it. 120 millimeters. Let's make some sparks. All set up for drilling and boring. Let's make a big mess on this machine with chips and coolant. This cutting tool is pushing a burr, and so after every pass I have this steel dish sponge, and you see here the burr. I have no idea why it's making burrs like this. I have not much experience with insert tooling, so if anyone knows, please tell me. I don't know what's happening. So after every pass I have to stop, and then with a rod I push from the other side, from the lathe, push the sponge out and then take a second pass. The piston goes in, so that could be good news, but the bad news is, while I was doing the finishing pass, there was some serious chatter problem. The cutting tool, there was a little chip, I have it here. I know you cannot see it on camera, but one of these corners broke, and because the whole part was flooded in coolant, I could not see what was happening. And so the whole surface is now completely rough and useless. So this beautiful little piston, I cannot use it anymore because I have to bore out bigger and then make a new piston. I managed to redo the inside surface. Now it's not perfect, but that will do. But now this boring is 51 millimeters, so the piston I have is too small. So I'm gonna have to make a new one, and this will be in steel because I don't have any cast iron anymore. Okay, I'm ready to drill this 6-bolt pattern here, and the way I marked it out was I used my little key for the tool post. Put it here in a dovetail, push to the stop, and then with the cutting tool I drew a line, and then second line, third line. I don't think it is the official way to do things, but that's how I did it. And then I made very light center marks here, and now I'm ready to center drill. Now this little machine has an whole story, and you can tell. You see there's lots of play here, but it's all I've got. We'll see how it works.